Hello, everybody. I really have a hard task because this is the first presentation after the dinner, and this is the second day of the conference. And my objective is not to allow you to fall asleep. Hopefully, this will be something interesting. Very enigmatic. Everybody is hearing me well? Yep. At least somebody respond. My very enigmatic title, we need a major step in maturating security. I will explain that in a few slides. Just a quick disclaimer that all the stuff that I will present in this presentation and on the following slides is my opinion, nobody else. Not my wife, not my employee, not my line manager, not my friend of my line manager, or whatever. All the stuff on this presentation is intended for education purpose only. Feel free to be educated, and no animals were harmed during the whole process and research that was done. Who am I, for those who don't know me? I'm working for more than 12 years in the security, and until last year I was working on the BlueTeam. In the BlueTeam, I graduated physics, and I'm very grateful for having that point in time when I was learning physics, because actually it occurs that applying all the rules that we learn during studying physics applied very well to IT security, especially that one, like, you want to test if something is stable, just shake it. If it will break it, it wasn't secure enough. As I said, for the last year, I'm trying to be a RedTeamer, so I'm gaining the experience as a RedTeamer, but deeply in my heart, I'm a BlueTeamer, so I'm always thinking, even when I'm breaking something or running a COBOL strike, I'm always thinking about the blue defense side. So the real problem that I would like to discuss here is the supply chain attack problem. So basically the problem, how can we make secure or more secure or fix some issues regarding shipping untrusted piece of software into our infrastructure. I know this is really a good buzzword for the past 2 years, but I will try to avoid buzzwords and BS in my presentation. So the motivation for this presentation started 1.5 years ago, few days after the SolarWinds incident. How many of you know what is SolarWinds about? Raise your hand. Okay, majority. So very quickly, SolarWinds is a software that is used in your network. It is a software that is being run in privileged endpoints. And basically, the attacker was able to compromise the pipeline the pipeline that is used to create that software, the binaries of that software. And by compromising that part, it is really big simplification. They were able to implant malicious components into the software that was later on installed. The malicious implant was present in the binaries for at least half a year, and it was installed in multiple institutions. And soon after the event called SolarWinds hack, the discussion on one of the professional social network portals started with this sentence, like, the SolarWinds hack shows that the automatic patching is not always a good idea, blah, 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 and very obvious and very correct sentence that you are responsible for what is being installed on your network. But the biggest problem in the supply chain attack is that, yes, you are responsible, but the garbage that you receive and you need to install on your network is being delivered by someone else, and there's no way that you can verify continuously verify the trust, especially that you have if you have multiple vendors that are supplying multiple things for you. So I responded quickly. Okay, how on earth can you? What kind of process can you apply to be sure, to ensure yourself or your organization, or to detect malicious intents in the software that is being shipped to you. Like the only thing that came to my mind, okay, I can take the binaries, I can install it on the sandbox environment, I can employ me or my friends to reverse engineer the software, analyze byte by byte every function that is there, and then I will be able to, in majority of course, claim that, okay, I didn't see anything suspicious. If you go to the doctor will never say to you, okay, you're healthy. The doctor will always tell you, I don't see anything suspicious. For me, you are not looking sick. They will not tell you that you're 100% healthy because you may not be healthy. So even if I would spend like, I don't know, half a year on reverse engineering, I wouldn't feel comfortable on telling somebody else that I definitely certified that this binary, especially huge binary, is definitely safe and free from the backdoors. And the discussion continues. I'm not saying that the manual installation is the answer, and the guy proposed 3 things. Check if the update is critical or not, and not install it. Like the whole idea of shipping the updates quickly is to install them, especially if the software is high privilege software. And in the most cases, vendors are not providing updates because they just, you know, okay, let's release the update. This is the 22nd of the middle of the summer, let's just release the update. They releasing update because they fixed something probably. Maybe cosmetic things like user interface button was moved left, or maybe a security issue. To check on the sandbox, if there's nothing suspicious, like I deeply believe that sandbox approach is working, but I will give a huge bottle of very pricey beer to person that would be able to run a very complex software on the sandbox and point a finger, okay, this is a malicious intent for all the hundreds of the behavioral things that were registered, like access to the disk, access to the memory, access to the registry, and all the other interactions. They will be able to point the finger and say, oh, this is definitely malicious because this IP address starts from 5. And to ensure that no external communication is being allowed. And this is very problematic because, for example, the SolarWinds needed a lot of network communication, of course, local communication, but if you, nowadays, it is hard to have a software that doesn't require network communication. Like, I don't know, most of them require, so even, for example, for downloading the updates. So yeah, this was perfect shot. Like, don't install updates, run your software on sandbox, and definitely this will fix the problem of supply chain attacks. No. And again, if you try to discover what's the problem with supply chain attacks, that's the problem. You have a third party that you cannot trust that is supplying you stuff, and you need to run it on your environment. And as I said, running stuff and analyzing the results, maybe if you're running malware and you definitely know what you're looking for. And it was a moment when corporal approach kicked in. I was in my tie, I was sitting in my shirt in my corporate desk, and my approach changes. We don't have problems, we have challenges. You're not sleeping, nice. So I ask myself, okay, I can argue on the LinkedIn, like everybody can do, but this is not moving us anywhere. Let's start thinking, okay, how actually we can approach that problem. So first thing of problem solving is we need to well define what is actually the problem. So let's start by trying to articulate what is the problem. The problem is who can provide the data about the expected behavior of the software. And of course, the obvious answer here is, like, you don't need to spend a lot of time on thinking, vendor, because they are building the software. So let's do this social experiment. Ask the vendor. So you're opening our Outlook, starting urgent request from our security department. Please provide the description, what is the expected behavior of your software. Let's assume that this is simple software, like, business calculation or something like that. Regards, foobar, sending the email. Waiting few days, waiting few more days, and the answer is coming. We are receiving the document with a logo. Second page, company mission. Second page, the list of things that will be in the document. And the description why this product is very special. And marketing description, what the stuff is doing, claiming to be a behavior description. And the Gartner square pointing like we're here. And we are very unique. And the statement that you need to think before printing this document. Like, I think majority of the people that are working in the big organizations would agree with me that this is something that you will get if you will ask vendors that way, like provide me the description. You will get the PDF, maybe a Word file, maybe a link to the website with all that very important information. And this is not moving us anywhere again. So the real problem is not who can provide the data, because the vendor, this is the obvious answer, but we just need to maybe ask more precisely for the data. So, okay, we're creating another email because this is response for the forward of the response. Please provide the list of domain IP addresses that your software needs to connect in order to work. Like, let's just focus on IP addresses. What you will get, let's like make a vote. Maybe there's something that you would like to propose. No, PDF. You will get an Excel file with a list of the domains. Okay, this is better because you can select a column, copy to the text file, and you will have the list of things that you need to look for. Or the opposite, you will get the list of the things that shouldn't worry you, but this is only this one software. Is it scalable? No. Did you get the answer? Partially yes, but only for the network connectivity. So let's move forward. How a responsible entity, and we assume here that this is a vendor, can provide the data about the expected behavior of the software. And the side question, what is the behavior? So let's pause here and think about fixing the supply chain problem in a modern way. We don't need machine learning, we don't need sandboxing, we don't need blockchain stuff and deception. Because we already have too many security software on the market. We have a network security protection prevention. We have like network intrusion detection, network intrusion prevention. We have pattern-based detection on the network and on the host and like inside the memory even. We have endpoint protection, signature-based, behavioral-based, stuff that is responsible just for monitoring and forwarding the data about the behavior to the central server, then to process it and apply the rules. Of course, we have stuff that is based on blockchain and artificial intelligence, but this is useless. And but this all stuff that I enlisted, and probably most of you are working on daily basis with that kind of software, is ineffective alone. Like a quotation from the Shrek, the security is like onion, you need to have layers. So you need to have layers of security products. You have an endpoint protection, because if the network protection will fail, maybe the endpoint protection will pick up the attack and alert you and maybe stop the attack. All the stuff that I listed here is very vendor specific. Like you are configuring the stuff in very vendor specific way. Most probably this is web interface that you need to click. Even if you apply fancy rules like, okay, let's combine detection of a specific, I don't know, execution path, etc. You are putting that knowledge and that configuration in web interface. Maybe in some cases you have a configuration file being uploaded, maybe. But this is very vendor specific. And definitely you cannot just ship this configuration when you're changing, I don't know, antivirus vendor from one to another. You cannot merge the configuration from one place to another because this is vendor specific. Even if you probably use the button export configuration, you will end up with binary crap that is only parsable by this specific software. So in the same category, like antivirus, endpoint protection, or network protection, the functionality is even heavily inconsistent. There's no like one baseline that we should look for There's no list of events that we should look on the operating system level. Most probably majority of the security solutions are logging things like, I don't know, create process activity. Most security processors are logging the network activity. But for example, and this is open question, I never saw a security product that was logging create process function call and the flag if the process is being created suspended or not. But everybody who was working on pair hollowing method knows that this is like the obvious way to detect that. And I didn't saw any kind of functionality on the market. Of course, there's an exception. Most of those security stuff is ingesting IOCs, but this is the result of the IOC becoming industry standard in terms of digesting things. A side question here, how do you store your configuration? You have firewalls, you have stateless firewalls, stateful firewalls, new generation firewalls, new generation Web 3.0 firewalls, endpoint protection, antivirus, EDR, host-based firewall, application whitelisting rules, yara rules, and whatever. Like you have multiple layers, and how do you store the configuration of those solutions? Most probably a case study based on firewall, good old. Sorry, this was the next slide. In most cases, in big organization, the configuration is stored in the series of Word documents that are describing the changes that you are applying one by one. Maybe the appliance is holding the recent version of the rule set configuration. And the only cold copy of that is if you are making a backup. Of course, you are making a backup or snapshot. As I said before, most probably there's no way to switch the vendor. If you, for example, will just switch the vendor of your firewall, like switch Palo Alto to Cisco Palo Alto, merging the rule set is a bit challenging, and there's no way that you will find a provider on the market that will say, okay, we will merge one and we will guarantee the functionality. Anyone storing that kind of configuration in Git managed to do that in the text files? So you're sleeping or nobody's doing that. Let's get back to the real problem. So let's apply again the corporate approach to solve the problem. Background is, how can we get the information about the intended behavior of the software? Current situation is that, as I showed, and nobody objected, if we will ask vendor, we'll get Word documents or PDFs. This is completely useless crap. What is our target? We want to get the knowledge about the behavior, about the expected behavior, and the way that the computers and the humans can read it, parse it, and consume it. The root cause is most probably there is no well-defined format to exchange that kind of information. What are the countermeasures? Let's propose the format. Let's do it. Like we did that. Years ago, we created an IOC standard. Like, how can we exchange the knowledge about behavioral events that indicates that your infrastructure being compromised? It's working. We are exchanging that data. We even have a fancy protocols of exchanging that data. The implementation plan, let's make a POC, ask people about the opinion, put stuff on the GitHub, and get drinks. So I'm introducing now the indicators of normality, the things that is quite obvious consequence of indicators of compromise. Why not indicators of compromise? Because if you are detecting indicator of compromises in your network, as I said, this is already a bad situation. So we need to reverse the process. Why application whitelisting is working? Because you're whitelisting the application. You know what you're whitelisting. You're not blacklisting things because you don't know what you need to blacklist, but you may know what you want to whitelist. Why? What do we want to achieve? We want to achieve the consistent way of describing the expected behavior. I'm repeating that like a third time or something. and it need to be exchangeable. It need to be parsable for both computers and humans, because otherwise people won't be able to assess if this set of rules or set of description is accurate or not. It should be a primary golden source for virus security layers. Like if we have this source of description, we later on can export or extract stuff from this configuration, sorry, from this golden source to our endpoint configuration, an endpoint firewall, EDR, or whatever fancy software you are using. And by defining the entities that we expect as being a description of the behavior, we can have a consistent expectations from the vendors. For example, if you have a very obvious description that we want to have the ability to monitor network security, we can expect that if we will onboard a vendor, we are expecting that this product needs to monitor network activity. Who is responsible? Vendors, of course, because they are shipping software. Security department, because some vendors are very hard to cooperate. So the security department will be responsible, or anyone, like IOCs are being created by the community. You can pay for generating IOCs, or you can generate them on your own, and it will work. The stuff will ingest your data, and you will get the detection. Why? Because we already put some effort on, we already persuaded vendors that are supplying us with the software to put some effort on the security. From the functionality perspective, and if you disagree, raise a hand, both things that I listed here, like a code signing and a hash publication, is completely worthless. Like, it is not adding additional security to the software. It is adding another security layer. Code signing allows you to sign the code, and if you download it, you are able to verify if that code was shipped and signed by this specific holder of this certificate. From the business perspective, this is a cost, because they need to acquire a quite costly certificate. They need to maintain the key management. They need to keep the key safe, because if the key leaks, you get the, I don't know, Windows driver signed by the leaked certificate. So this is costly. And from the overall perspective, this is not improving, I don't know, the quality of the software. The software is not running faster if it is being signed. Hash publication. This is maybe not so cost ineffective, because you just need to calculate a hash of your binaries and publish them on your website. But this is an additional process that is also not improving the efficiency of your software. This is just a security feature that allows people, when your code is, for example, not signed, to verify if they have the right binaries on the disk. Like, very simple operation. Do's and don'ts. The thing that I would like to propose is the idea may help to improve or solve partial problems with the security, especially in terms of shipping a third-party stuff in your infrastructure. It is just a format. This is not an implementation. This is not a solution. I'm not creating EDR, XDR, endpoint protection, firewall, whatever, and definitely not a blockchain. This is something like IOCs. IOCs is just a specification, how we will write the data. And definitely this is not a silver bullet. This will not solve all the security problems. This will help us to improve the security and maybe fix some specific problems. Let me show you what I had in mind when I was working on the format. We have already rules that are human and computer readable, like Sigma rules, Yara rules. Anybody here wrote a Swagger OpenAPI profile for your web application? Yes, you see a few people. Like, you can describe in human readable form what your whole web application is implementing, like all the possible HTTP requests that can be done to your application, and you have a way to describe that. And this is still human readable and computer readable. Rules that need to be human readable, well structured. You need to be able to make a very easy way, a diff between two files when something is changing. And the benefit of that, you are able to store it in the repository as a text file, so you are able to track the changes over the time. Rules in that format can, the purpose is that those rules can be later on translated, exported, or I don't know, compiled to the other formats. So for example, to AppArmor, Linux, AppLocker, Sysmon, Protsmon rules, whatever you have in your infrastructure. AppArmor is a very good example because they already providing very similar functionality, but please raise a hand whoever read AppArmor configuration file, like look inside, 1, 2. It is working, but this definitely the part of human readable is not working there. Like, yeah, you can take a piece of paper and start drawing things and maybe you will understand, but this is definitely not so obvious. And let's apply some good old Python Zen, explicit over implicit. The readability is important. If our format needs additional explanation, this is a bad idea. So this format needs to be easy to understand even for the person that didn't read the documentation for that. So yeah, this is the format how we will store it. The problem, of course, quickly we'll pick up the problem that there's a problem of signing those rules, because if the vendor will be releasing them, we need to have a way to verify the integrity of the file, so we can put them into the JWT, so the vendor can sign it. Probably maybe using even the same certificate that you're using for code signing, which is this asymmetric key. And this is an example of the rule. We have very simple structure. We're defining we have categories like network behavior, file system behavior. Let me show you the file itself. Yeah, so we have some metadata like in other formats. Targets, so we're defining what files, to what files should we apply this rule set to. And basically the rule set is here. So for example, for network, we specify that this piece of software is allowed to connect to the example com on port 80. If our solution is allowing us to implement layer 7 inspection, we have the information that we expect HTTP there. If our solution is not allowing us to do so, we just can live with port TCP and only that information. On the file system, we can specify what paths, what files can be open and accessed by the software. And the idea behind the whole rule set is to apply the allow-deny order. So if something is not being allowed explicitly, it means that it is not being allowed at all. So if you don't want your software to touch the file system, you're just leaving the file system section empty, and basically it means that your software doesn't supposed to touch anything on the disk. Exec means what kind of child processes should be allowed to be spawned by that process. Registry, this is very platform specific. Parents means what can we expect in terms of our process being spawned from. And environment means that we can put some information, what are the allowed or not allowed environment variables that are being used by our software. This is like quite basic. The format is extendable, so we can, if we think about like, I don't know, maybe let's add what is the current temperature in the room, and the software only needs to be operated in a specific range of temperature. We can add a section here, not a problem. How to generate that stuff? Vendors can use a code annotation. They are already using code annotation to generate the documentation. Like whoever spent some time on developing software knows that in most modern programming languages, you can put a code annotation in the comments in your code, and just by having them in the code, you can create a documentation that will describe how your code is working, what, I don't know, API are you exposing. So we can try to make a code annotation. So for example, if we have, and this is an obvious way to do that, if we have a function that is, I don't know, loading a configuration file from the disk, we can add a code annotation that we expect read and write access to the specific file on the disk. Of course, we can generate that profile by sandboxing, monitoring, etc. So we can just list the events that are happening and add them to the whitelist. Or we can just do the manual work. And let me show you an example of the rule. For example, a very obvious rule for Notepad. Okay, so this is a rule for the Notepad. Notepad's supposed to, oh, this is not displaying correctly. Yep, Notepad's supposed to open, read and write files on the disk. It doesn't supposed to, I don't know, do a network communication, spawn a process, I don't know, execute anything. Like if you will see a Notepad spawning a new process, this is definitely not something expected from the Notepad. So in this way, in those like few lines of text, we created a profile for a Notepad, a thing that is being commonly used in very naive exploitation paths, but like it will work. Later on, you can fit that knowledge into your security solution and see like if there is something that is not fitting the profile, this is definitely the indicator of being compromised. So we're going back to the indicator of the compromise, but we don't need to define explicitly that we are looking for something malicious here. And let me show you an example how we can see the changes in the file. Okay. Yeah, so even if the attacker would manage to compromise the supply chain of the vendor, and even if they manage to compromise this ION rule set, and the vendor will publish, like they will be, I know, stupid and will publish anything that will be delivered by the pipeline. Anyone without any reverse engineering can take a look on that and see, okay, so somebody added a huge section here, and the software that previously over past 5 years was not executing anything is allowed to execute arbitrary binary from the disk. There are still some open problems, like how can we pin policy to a binary using hash, signatures, etc. How can we handle script interpreters or lol beans? This is an open subject. One of the ideas is here to create a a pattern for what arguments for the process are being allowed. And in terms of networking, there's always a problem in domain name resolution versus time to check versus time to use, DNS rebinding, etc. But I think those are the minor problems here. I want to give a big thank to everybody who I asked about the opinion or help on that subject here for over the past year. I don't want to list them because there's like a huge list of the person and I may miss somebody. So big thank you to everybody who helped me on improving that. Please feel free to contribute.